Okay, question 14. We have a velocity time graph. So the graph below models the velocity of a small train as it moves along a straight track for 20 seconds. The front of the train is at point A when t is equal to 0. The mass of the train is 800 kilograms. So here's our velocity time graph. Part A wants us to find the total distance travelled by the train over the 20 seconds. So on a velocity time graph, the distance is the area under the curve. So first up, let's just call this D1. So it's a trapezium. If you can't remember the area of a trapezium, break it into a rectangle and a triangle. So our base is 10 long, our height, or our top length, is 6 long, and our height is 8. So D1 is equal to 8 times 10 and 6, so 16 all over 2. So that's 4 times 16, which is 64 meters. And then this other guy, let's call it D2. It's a triangle, and we know the base is 10, and we know the height is 2. So D2 is base times height, so 10 times 2 over 2. So that's actually just going to be 10 meters. So our total distance travelled is is 64 and 10, which is 74 meters. Part B wants us to find the distance of the front of the train from the point A at the end of the 20 seconds. So remember the question that said when t is equal to 0, the front of the train is at point A. So when velocity is positive, the train is moving forwards. So in the first 10 seconds, the train moved forward. Then we know the distance it went forward is 64 meters. Then, when velocity is negative, the train is going backwards. So we know it went 64 meters forward and then 10 meters backward. So it's going to be 64 meters minus 10 meters, which is 54 meters. Okay, part C wants us to find the maximum magnitude of the resultant force acting on the train. So, force is mass times acceleration. So for that to be as big as possible, we need to find the greatest absolute value of the acceleration. So A max. Let's see. So from a velocity time graph, acceleration is gradient of the graph. So the steepest part of the graph is this section here. So the acceleration would be, if we do it as 8 minus 0 over 6 minus 10, and then we get 8 over minus 4, which gives us minus 2. Now the reason that is negative is because during that time the train is slowing down, so it's actually decelerating. But that still is a type of acceleration. So the absolute value is 2 meters per second squared. So force, or the maximum force, is the mass, so 800 times 2, which is 1600 newtons. Cool. Okay, then part D wants us to explain why, in reality, the graph may not be an accurate model for the motion of the train. So, on the graph, everything is, or every section, is a straight line. So in each section there is constant acceleration. So our acceleration is like immediately changing from one thing, from one constant value to another constant value. In reality, that doesn't happen. Acceleration gradually changes. So the graph should really have curves in it, not all straight lines. So if we say something along those lines, that would be absolutely fine. Cool.